Differences between low density polythene and high density polythene. Some important points we can consider here. Low density polythene is LDPE, high density polythene is HDPE. Both are coming from same CH2 double bond CH2 only. So what are the differences in these two? That point we'll discuss now in detail. Low density polythene is obtained by the polymerization of ethene CH2 double bond CH2. When this is undergoing polymerization, then you will be getting their CH2 single bond CH2 taken in. This is low density polythene. Formula will be same, but the condition required here is 1000 to 2000 atmosphere pressure and around 350 to 570 Kelvin temperature. And peroxide initiator is like catalyst. Peroxide initiators are required. You can say this is catalyst. You can see our previous mechanism also, previous class you can see. In that we were discussing in detail about ethene polymerization. The low density polythene is obtained by the free radical addition of hydrogen atom abstraction. This is a very regular point. It has highly branched structure. These polymers have straight chain structures with some branches as shown below. As shown below. I am taking the sentences as it is of NCERT. See, these are some branches. So what are the special lines about this? This is chemically inert in nature. Important points which can be asked in examination. And it is tough. But interesting point is flexible. And one more interesting is poor conductor. Ethylene is not a good conductor, poor conductor of electricity. Generally, when it is poor conductor, you can very comfortably use in insulation process. Insulation of electricity. Electricity wise purpose, whatever the insulation we are going to do, there you can use because it is poor conductor of electricity. And in squeeze bottles, these examples are asking nowadays in squeeze bottles preparation it is used like that. Toys and flexible pipes, it can be used. Uses. So what is about low density polythene? Low density polythene is nothing but a polymer of ethylene when it is polymerized at 1000 to 2000 atmosphere pressure, 350 to 570 Kelvin in the presence of peroxide catalyst. It will be having some branches. It is inert in nature. It is tough. It is flexible. Poor conductor of electricity. Used in preparation of squeeze bottles, toys, and flexible pipes. If you remember these points, that's more than sufficient. Coming to high density polythene. What are the important lines of high density polythene? It is formed when addition polymerization of ethene takes place in a hydrocarbon solvent. Hydrocarbon solvent. Hydrocarbon solvent means like higher alkanes. And catalyst here is Ziegler-Natta catalyst. Ziegler catalyst. And particularly we say here is Ziegler-Natta catalyst. What is Ziegler-Natta catalyst? It is titanium tetrachlorate, TiCl4. This point we were getting in other topics also. Triethyl aluminium. Okay, now Al(C2H5) taken thrice. Trimethyl also you can use, no problem. TiCl4, Al(C2H5) taken thrice. This is Ziegler-Natta catalyst. In D block elements, if you see the uses of the D block elements, there it is mentioned methyl. So you can use ethyl or methyl, trialkyl aluminium, titanium tetrachloride. This combination is called Ziegler-Natta catalyst. Temperature is 330 Kelvin to 343 Kelvin. Not a very important point, but this is important. And pressure is also very less pressure, 6 to 7 atmosphere. Here you see this is 1000 to 2000. Here it is 6 to 7. Here 350 Kelvin. Here 333 Kelvin. Here catalyst is peroxide. Here catalyst is Ziegler-Natta catalyst. If you remember this, that is easy to remember. And here no branches, only chains will be there. And this is also inert in nature. And when you compare with the low density polythene, high density means it is definitely more tough and more hard. It is used in the preparation of buckets, bottles, pipes, and NCRT example is dustbins also. It contains only linear molecules. Here you see, here branches are there. Such kind of branches are not here, only linear. So, of all this, what I feel is more important one, Ziegler-Natta catalyst. Teacher's choice question, Ziegler-Natta catalyst. Remaining cannot be asked where it is used. Okay, now. So for electrical insulation purpose, LDP uses. This is my second choice. In this, if I want to prepare the question paper, I will go with these two.